Wonderful. So this is one of the most beautiful problems that I have solved on Leetcode in a while. So in this video, we'll be solving Leetcode problem number 962, maximum width RAM. So in this problem, we are given an array, and what is that we have to do? We have to find a pair. Now, what is a pair? A pair is such that the right element is greater than or equal to the left element. Now this can form a pair. Now this 0 and 1 can also form a pair. Now there can be many pairs, right? So what is the problem requirement? The problem requirement is such that they have to be farthest along. For example, these two form a pair, that's fine. But this 0 and this 5 can also form a pair. Now what is the length of this? The length of this is 4. So this will be our answer because this is the largest that can be formed. We can form any other pair, this 1 2, this 1 5, any pair, but this is the pair with the maximum distance. So that will be our answer, that is 4 in this case. Now we can take a similar example. So this one can form a pair with this one, and the length that is equal to 7 will be our answer. Now let's arrive at the optimal solution of this problem step by step by solving or by looking at the brute force approach. So this problem beautifully explains how you can go from brute force approach to the most optimized approach. Now let's understand what is our brute force. Now what is our brute force? For this 9, we go on and say, can I form a pair with this? No. Can I with this, with this 9? Yes, I can form a pair, and it will go through all the elements, and for this 9 we will find the max width. So then again for this 8 we will go through all the elements and find which is the optimal, and we will go on. So what is the order of complexity? The order of complexity will be n square, because for every element we are going through all the elements. But can we reduce this? Okay, let's try this. So for this 9, instead of starting from this 8, can we just start from this 1? Why? Because we are looking for the farthest element which is greater than this, right? So we need not go from this. Once you have encountered that farthest element, for example, this 9 will find this 9. All right, so once you have encountered this, do you care about any elements in between? There could be 100 here, but it doesn't matter, right? Because this has found the its pair which is the longest length. So still this will be the order of n square, but we have reduced some time complexity. How? For example, this one will not start from this 0, will start from this one. So if it has found a pair at this one, even this 4 will match the condition, but we don't want that because we have already found the farthest pair. Now once you have done this, what we need to understand, let's take the same example and let's paste it here. Okay, so now what is that we have to do? So we know for this 9, all we have to do is find the largest element or the element on the left side. So what we will do is we will have a track of all the elements. Say for example, once you have encountered say 1 will be the maximum element, and then we will go on to 4, which is our maximum element. Now does this 0, will that 0 be of any value for us? No, right? Why? Because we have an element that is greater than that element on 4. So any number that could have formed a pair with this 0 could form a pair with this 4. So this 0 in a sense is not useful for us. So what we can do, we can just save the 4 here. Same goes for this 4 as well. Then but this 9, that is not the case. Why? 8 can form a pair with this 9, but 8 cannot form a pair with this 4. So what is that we are doing? We are storing the maximum element. We are just storing the maximum element, and we have started from this side. Once we have stored all the maximum elements from the left side, now this problem becomes very easy. Let's compare this with the original one. So what it says is, this 9 will say I want the best pair. So how can we find the best pair for this 9? It will go on, so it will say 9. Okay, this is me. It can I go, it can it go ahead? Yes, it can go ahead. It can go ahead. It can go up till this point and say, oh, I encountered a number that is lesser than me, so it means that I cannot form any pair from this point onwards. So the best pair for this 9 has been encountered, and that will be this number. So whatever is the length, we can find it out and figure it out. Now we will go to the next element. For this 8, again the same thing happens, right? We don't care, we need not iterate all these elements once again. Why? Even if we find a pair here, it says that, sir, even if I find a pair here, the length will be lesser than the previous length, right? What this 9 has formed, it's 1 2 3 4 5, the length is 5. Even if I form a pair with these 9s, though I can form it, but its length will always be lesser than the first pair. So it will once again start from this 4. It says it's of no use to me, and none of these elements will be of any use to it, so it cannot form a pair. So it will just go to the next element. Now this 1 will go to this 4. Can it form a pair? Yes, 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 yes. So we have found the maximum, that is we approached at the rightmost element. Now you will understand this even better once we go through the pseudocode. First thing, what we will do, we will have a maximum array that we found from the right side. So that is what we are doing in this step. Once you have done that, we will have a 2 pointer. One is left, that is for the main array, and one is right, that is for our array that we formed, that is for the max array. And we will check, we have not iterated all the elements, and this condition we will check. What is it that we are checking? Right should definitely be greater than left, that is when we can form a pair. And if the element is greater than this, what it means is I can go to the next element. That is, it has encountered its best element. That is the element on the say for example we took 0th index element, right? And it has approached its best. So once it has found its best, you can just go to the next element. Now while going to the next element, what we have to do, we have to get this answer as well, which is the ramp length. Once you are done with that, you can do array plus as well. Thank you for watching the video. Please do like, share and subscribe.